In this video, you will find out what exactly is NGINX, how it works, and what it can be used for. Let's get started. NGINX was initially released on October 4th, 2004 to address the C10K problem, which allowed it to handle high concurrency and numerous simultaneous connections. Over the years, it has evolved significantly, introducing features like OCSP stapling and HTTP2 support, ultimately becoming a leading web server and reverse proxy solution used by major enterprises worldwide. Today, it continues to innovate under F5 networks, adapting to modern web technologies like HTTP3. A basic use case is when a browser requests a web page from a single web server. The web server has software that assembles the web page and sends the response back to the browser. That web server software can be NGINX, a piece of software running on a machine that responds to requests from a browser. But then, if a website becomes popular and millions of requests are made simultaneously, that's way more than a server can technically handle. To fix this, we need a few more servers to manage that load. So, we add 3 NGINX web servers. But now, we need something that determines where requests from the browser are routed, which one of the 3 servers will handle them. That's where load balancing comes in. The load balancer stands in front of the web servers and proxies the request to one of these servers. How does it distribute the load? It depends on the load balancing algorithm that's set up. It could be round robin, a popular algorithm that distributes requests in a rotating sequence, or least connections, which directs new connections to the server with fewer active connections. There are also other more complex load balancing methods. So far, we've seen NGINX as web server software and the NGINX load balancing function, which is actually part of the NGINX proxy server functionality. Besides load balancing, it also offers caching and security features. Imagine your website becomes popular and millions of people access it from their devices. If every time a request lands, one of the web servers has to assemble the response, put everything together for the visitor to see on their browser, and send it back as a response, that would happen millions of times. Not very efficient, right? Instead, it makes more sense to assemble the website once, store it, and then just keep that version to send to every visitor who requests it. That's caching functionality, and it's a core feature of the NGINX proxy server, which not only speeds up website loading times, but also reduces backend load, improving server stability. Now imagine we have 100 servers for a bank. These servers are prime targets for hackers who want to access personal data, financial information, or anything else they can find. If you expose all these servers to the internet, you've actually made the hacker's job easier. They only need to find one vulnerability in one of those 100 servers, and from there, they could break into the entire system. So you'd have to work to keep each server absolutely secure, with all the necessary packages, configurations, and so on. Instead, by making only one server publicly available, you can focus all your efforts on securing that one server, rather than maintaining 100. This setup acts as a shield or security layer. Talking about security, one essential measure is encrypted communication. Here, the proxy's functionality includes accepting encrypted traffic by enforcing HTTPS with SSL encryption and rejecting non-SSL traffic. Now, you might wonder how to configure these things. How do you set up NGINX to run as a proxy server or a web server? And how do you configure caching, SSL security, and so on? That's where the NGINX configuration file comes in. The usual location is in the etc. NGINX directory. The NGINX file uses a custom syntax comprising directives and blocks that set up the server's behavior. In that file, You define whether you want a web server or a proxy server simply by configuring whether it should forward traffic or handle it directly. You can also configure which port you want NGINX to listen on. As you can see here, we have port 80, which means it's an insecure port. Port 80 is the default for HTTP, but does not encrypt data, making it vulnerable to interception. It's great for demo purposes, but not recommended for production without HTTPS. On the right side, we have port 443, which adds encryption, securing data from client to server. We also redirect HTTP traffic to HTTPS to enforce encryption. The SSL certificates are necessary for secure communication and prevent not secure warnings in browsers. We also have its own configuration for load balancing. Upstream block. This defines a group of backend servers, 3 nodes, in this case, under the name MyApp. Requests will be distributed across these nodes. Proxy pass. This directive forwards requests to the load-balanced upstream group MyApp. Proxy set header directives. These ensure that the client's original information, such as the host and IP address, is passed to the backend servers. The default load balancing method is round robin, so no additional configuration is needed if you want to use that. Requests are distributed equally across the nodes in a rotating fashion. To balance the load based on the number of active connections, you can use least con. This routes traffic to the server with the fewest active connections, making it ideal for servers with varying workloads. You can also use IP hash for sticky sessions, ensuring that requests from the same client IP go to the same server. Or weighted load balancing to direct more traffic to specific nodes. You can assign weights. Higher values mean more traffic. We also have caching configuration, where we can define multiple elements, like how long the cache should be stored, and so on. You can pause the video to go through the configuration displayed on the screen. To dive deeper into NGINX and explore all available configuration directives, check out the official documentation at the link provided, which you can also find in the description. Thank you for watching. Don't forget to leave a like and subscribe if you want to see more similar content, and I'll see you in the next video.